set notation. Now, those are the symbol that you see in set for you to be able to form your question with a set. It is related to what we have been talking about so far. Those type of set, the element of set, what we have talked about since, what we have been talking about since, are also part of what we are going to be making use of here. For instance, if you have this set of elements, B, A, if A is 1, 2, 3, 4, the element we have there, 5. And don't forget, I've told you, this is a symbol you make use of. And B, the element we have in B, A, B, C, D, E, F. Now, by looking at this expression very well, you can agree with me that I can say X is not a member of B. This symbol or the notation I have here, this translation of this expression here means X is not an element of set B. You can see that when you look at B very well, there's nothing like X there. So X is not an element of set B. But I have this A. This means A is an element of set B. A is an element of set B. You can see this is A there. It's among the elements we have in set B. Now, I have these two sets of elements. None is a subset to one another. But I can say that A, what do I mean by this? What I mean by this is that A is a subset of A. Don't forget, I have said it earlier. I said that every set is a subset of itself. Take note of that. It's very important for you to know that. So A is a subset of A. Also, B is a subset of B. Now, if I now have C to B, let us know I have set of elements of which is C, which is like this. If this C is a 3, 4, 5, I can say that C is a subset of A. C, this means C is a subset of A. You can see that all the elements I have here, 3, 4, 5, are also A. But there are some elements that are in A which are not in this C here. So C is a subset of A. So that is very clear. Now, we can as well now say that A is a superset of C. That is, A is a superset of C. You can see all the elements that are in C are in A. So A has some values or elements that are in it which are not in B. So it makes it to be the superior over set of C. Now, if I have this, or this is what we call a null or empty set. I think we have discussed what is meant by null and empty set earlier on, which means, for example, if I say a child born without a head, that is a null set. It cannot come into it. There's nobody on this planet Earth that is existing without a head. There's no one. So this is what is called a null or empty set. That is a symbol for it. So we have, then we can talk about universal set, which can be represented by this or this. That is universal set. Universal set. You understand what is meant by universal set? Every set that are being collated together, which have subdivision that or subset that are found within the universal set. Universal set can as well have some set that are even that might not even be found in any of the subset. That's why we call it a universal set. And we have what is called a union of a set, which is represented by this symbol, union of a set. When you are talking about two sets, what those elements that are inside the two set, you are going to bring them together. That is what is known by union of a set. We have what is called the intersection of a set. Intersection of a set, that is what is common between the element or between the set you are talking about. For instance, here, if I have what is the A intersection C now, I can now have it as if I have to find the A intersection C, this would be equal to what is the value that are common to them? 3, 4, 5. That is the A intersection C. You understand what is meant by intersection right now, and we understand what is meant by union as well. Also, what is meant by the complement. You have the symbol of complement of this nature. It can be A like this or A complement. This means A complement. Now, A complement, if I have the universal set here, you'll be able to identify what's meant by A complement. A complement are those values that are inside the universal set but are not in this A itself. So we have a topic before us today on mathematics called set theory. How do you define set theory in mathematics? Before I go into the definition, I want you to know the importance of set theory in mathematics. Set theory in mathematics is very important that most of our undergraduate students, most of the students that want to write the examination to go into the higher institution, is very important. They have detailed knowledge about set theory. In other words, set theory is very important topic in mathematics. Now, before we go deeper into talking about what set theory is all about, let's define set theory. A set is defined as well-defined collection of data, informations, or any forms of informations that you try to put together to show a particular forms of mathematical expression. In other words, for you to identify set theory, you have to use this symbol to represent your set. This symbol is a symbol that you use in representing the set. That is where all the set information will be enclosed within. Now, in set theory, what the values that will be placed inside this symbol, for instance, if you are asked to give the prime numbers between 4 and 10, prime numbers between 4 and 10, you are going to have it this way. You have it to be 5, 7, I think that is all. That is prime number between 4 and 10, 5 and 7. Now, you can see that this is a symbol that identifies set theory, and this follows all these particular figures you have inside this set theory, or whatever that is placed inside this set symbol, are called elements of a set, and you can also refer to them as members of a set, element of a set, or members of a set, element of a set or member of a set. Now, before we now go deeper into the solving of different problems as regards set theory, I want you to take note that before the end of this class, you are going to have knowledge about the type of set that we have, the terms that we use in set, the set notation, and some other important information that are going to be useful for you when you want to have any problem that have to be solved in this form of set theory. At the end of this class, I give you the assurance that you must have gotten detailed knowledge about all this information. Now, before I go deeper into this set theory once again, I want to introduce you to numbers in mathematics, because by the time we start with set theory, all this information will be making use of, and by making use of them, if you have detailed knowledge about them right now, it will be easier for you to know how to place those values there appropriately. Now, in the numbers I'm going to talk about, I'm going to make use of number line. This I call number line. This is 0. The negative value will be here. -1, -2, -3. It goes on like that. This is 1, 2, 3, and it also goes on like that. Now, this arrow shows that this set of values that we have here, these figures, are increasing towards the right hand side. Now, for me to place my numbers, I'm going to start with the natural number. These are called natural numbers. Numbers that are whole numbers, not natural numbers. Natural numbers are whole numbers that start from 1, 2, 3, 4, 5 till infinity, and they are represented by this symbol, capital letter N. It is important for you to know this symbol, because in most cases when you are given a question under set theory, nobody is going to write for you, this set is a natural number. They will just make use of these symbols for you to be able to know how to place your appropriate value there. Another set of numbers that we have are from the 1 again. These are called the positive integers. Positive integers. They can as well be related to natural number because they are the same figure. They start from 1. They are also whole numbers, 2, 3, 4, and like that to infinity. Now, you can see that this is 0 here. If I take this 0 here, alongside with all these positive integers, I call it non-negative integers. They are called the non-negative integers. Any number that starts from 0, if you include 0 with the positive integers, they are called the non-negative integers. In other words, the integers are represented by this symbol, capital letter Z. That is the symbol that we use in representing your integers. Now, the numbers that are in the negative part here, from -1, also whole numbers towards this left-hand side like this, are called the negative integers. Negative integers. These are the set of numbers that I'm going to stop here as far as the numbers in this regard are concerned, making use of this number line. I can still talk more and more about numbers, but I'm going to talk about those ones that are important for as far as set theory is concerned. We can still talk about rational number, non-rational number, the so-called and so on and so forth like that. Now, the next one I'm going to be talking about is called the factors of number. Factors of number. The definition of factors of numbers are numbers that can be divided by a number without a remainder. If you are given a particular number and you are asked to find the factor of such a number, the number that you can use to divide such a number without a remainder are the factors of such a number. For instance, if you are asked to find the factor of 4 between 8 to 20. 8 to 20. Now, factors of 4 between the values of 8 to 20, this will be from 8 now. 8 can divide 4 to have a whole number. 8 divided by 4 will give us 2. That is the whole number, 8. What else can divide 4? 9, 10, no. 11, no. 12. 12 can divide 4. What else can divide 4? We have 16. 16 divided by 4 will give us 4. And the one we have again is 20. Those are the values that can divide 4 without remainder. So also if you are asked to find the factors of any other number, for example now if I want to talk about finding the factors of 5 between 5 and 25. You have to look for those values that will divide that 5 without a remainder. That is what is called factors of number. Another number we are going to talk about here is called a perfect square. How do you identify a perfect square? A perfect square are identified by multiplying every number by itself. When you multiply every number by itself, the value it gives to you are called the perfect square. For instance, we have when you have 1 times 1, that will give us 1. 1 is a perfect square. If you have 2 times 2, that will give us 4. If you have 3 times 3, that will give us 9. In other words, now, the value that we are able to get here as our answers, they are called the perfect square. In other words, now, I can name my perfect square from 1 to 40. Perfect square between 1 to 40 will be, I'll have it here, in this form of set like this, that will be 1, 4, 9, 16, 25, 36. So those are the perfect square between 1 to 40. That is a value we are going to get for perfect square between 1 to 40. Now, another number that I'm going to also talk about are called the prime numbers. Prime numbers. Prime numbers are numbers that can be divided by 1 and itself to give a whole number. If you use any value to divide such a number, the value you will get will be in the form of decimal point, decimal values. So in other words, any values that you can divide, that can only divide by 1 and itself, are called prime numbers. Example of prime numbers now. Example of prime numbers, we have 2. Prime numbers start from 2. 2 divided by 1 is 1. 2 divided by 2 is 1. 2 divided by 1 is 2. 2 divided by 2 is 1. 2, we have 3. We have 5. We have 7, 11, 13, 17, and so on and so forth like that. Those are very good examples of prime numbers. Now, odd number is another number that we also need to talk about when we are talking about the kind of values that we can be asked to bring out their information when we are talking about set theory here. Odd numbers are numbers that are not multiples of 2. As you have it here. Numbers that are not multiples of 2. Numbers that are not multiples of 2, those are the odd numbers. And example of odd numbers can be, odd number start from 1, 3, 5, 7, 9, 11, 13, 15, and so on and so forth like that. That is the meaning of odd numbers. Odd numbers. Now, the other number I'm also going to talk about here in this class, which I will, from that I can take a break there, is called the even numbers. All of us are familiar with most of these numbers, but we must let them also be part of what we will put in our memory always, so that when we are trying to deal with this set of information as regard set theory, they will be useful and will be able to answer the question appropriately without making any mistake. Now, even numbers are numbers that are multiples of 2. So, example of even numbers, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on and so forth, etc. Now, these are the set of numbers that I think we are going to be making use of those information as far as this class is concerned. I hope you are going to stay tuned, as we are going to be using this set of information to solve some problem as regards set theory. A particular question given to me in this order. For instance, I have this. A is equal to something like that, this nation. y. Then you have this column given here. There, y is odd number with odd number less than 10 less. As a student, you should be able to know how to translate this set notation. How does this one mean? Now, this one reads this way. It reads that A is a set such that A is a set such that y is an odd number. Y is found within A, which is an odd number, less than 15. Now, you need to write the set of that A out and show us the element there. So A will now be equal to, is what? It reads that A is a set so that Y is an odd number less than 15. Now, what is meant by odd number? You know, we have been able to touch what is meant by numbers as when we started the class on set theory. Now, what is meant by odd number now? Odd numbers are those numbers that are not divisible or multiples of 2. They are not multiples of 2. When you do the division of them by 2, there is going to be a remainder. Those are odd numbers. So we have 1, 3, 5, 7, 9, 11, 13. How many numbers there? 1, 2, 3, 4, 5, 6, 7. Those are the numbers that are found that are elements of A, according to this information given to us here. This is how the question are always given to students, and you are expected to be able to know how to write it out in this way. You know that you should be able to know that you can use this that information now to answer different questions. This information you have here now, you can be asked to find the number of A, you can be asked to find the number of subset, you can be asked to find a complement if the universal set have been given to you, and you can be asked to use it to find anything. So make sure that you take note of how you solve the question. Now, I'm going to give you another notation now. You have this. B is an element such that, taking a look at this expression very well here, you can see that the translation of this particular set notation that we have here means that B is a set. That is what this one, B is equal to a set, such that A is a member of, what is this symbol? What is this symbol? This symbol in numbers, representation, the symbol that we represent by this capital letter Z is integers. B is a set of numbers such that A is an element of integers. You can see now, look at this expression of A here. If you look at it from this angle of where we have this A, what this one means to this A is that 6 is less than or equal to A, or A is greater than or equal to 6. That is integers of an element, that A is an element of integers such that A is greater than or equal to or equal to 6, and less than or equal to 15. Now, this is the translation of this particular set notation that we have here. Now, if I want to have it in forms of mathematical figures, I'm going to write it this form. I have B equal to, here's this set notation. Now A is greater than or equal to 6 is a natural number. You know that natural numbers are whole. This is an integers. Integers are either positive integers or negative integers. The one we have here belongs to the positive integer, is greater than or equal to 6. That is going to be, so 6 is going to be inclusive because the question says it is greater than or equal to 6. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those are the elements that you will find in B that is the one that we have here right now. If you look at the number of this element now, you can see that 15 is inclusive because the question says that it is less than or equal to 15 and greater than or equal to 6. That is how you are going to represent this set notation. We'll be going into the question proper now. We're going to look now. This question we have here now says that in a class of 68 students, out of 68 science students in a school, 30 take chemistry. Now, for us to look at those that are taking chemistry now, let's say let me represent them by C. C represent chemistry, and number of students that take chemistry are 30 students. 30 take chemistry. According to the question, as we read it further, 50 take physics. I will use P to represent physics. Physics. How many of them? 50. That is, number of students that take physics is 50. Then, what other subject we have here is biology. 24 takes biology. I will use B to represent biology. Biology, which is what? That is 24. 24 student takes biology. Now, if 14 takes chemistry and physics, now this is number of biology, this is number of physics, and this is number of students that take chemistry. Now we now have a question that goes further and say if 14 takes chemistry and physics, if 14 takes chemistry and physics, number of chemistry intersection physics now, that's 14. 14 takes chemistry and physics. 10 takes chemistry and biology. Number of chemistry intersection biology is equal to 10. And what else we have 10 take chemistry and biology. We have 14 take chemistry and physics. 22 take physics and biology. Number of physics intersection biology is equal to 22. 22 takes physics and biology. We are now asked for how many students take all the three subjects. Now, from the question given to us, we have been able to see that we are only having these three set of subjects in that science class, and which each of those students are taking any of these three. Some of them take more than one, some of them take all the three. Now, all the students that take all the subjects, there will be number of chemistry in union biology, union physics. Number of chemistry, union physics, union biology is equal to 68. Don't forget, the question reads out of 68 school students in science class. Then they gave us all this information that we have written out here. Now, we are now asked for how many students takes all the three science subjects. For you to take all the three science subjects, that will be what? Number of chemistry, intersection physics, intersection biology. If you want to take all the three subjects, those are the students that take all the three subjects. So if you drawing the Venn diagram for this now, we can now have it in this way. This is, let's say this is physics, chemistry, and this is biology. Now, for the number of students that take that are sheeted in chemistry, that's 30. For physics, that is chemistry is 30. That of physics is 50, and that of biology is 24. Chemistry and physics This chemistry and physics, this is going to be the region that is 14. This is chemistry and biology. This is chemistry and biology. This is going to be the region that is 10. And physics and biology. Physics and biology, that is going to be equal to 22. You can see this is physics, this is biology, that's 22. We are now asked to find the number of students that cheated in all the three subjects now. Now, we are going to make use of this particular number formula. That is number of chemistry union physics union biology is equal to number of chemistry plus number of physics plus number of biology minus number of chemistry intersection physics minus number of chemistry intersection biology minus number of physics intersection biology plus number of chemistry intersection physics intersection biology, which is going to be equal to, which we have the value for this already, that is the number of chemistry union physics union biology. That one has been given to us to be 68. 68 is equal to number of chemistry 30 plus number of physics 50 plus number of biology 24 minus number of chemistry intersection physics, that is 14, minus chemistry and biology, that is 10, minus 10, minus physics intersection, that's 22, plus everything we have here, number of chemistry intersection physics intersection biology. Those ones that are common to the three of them, that is the value that we have here. You have not put any, there is no value here already now. Now that's what we are trying to find out here now. Now we are going to now have all the total number to be equal to, or you cannot have it to be equal to 68. If you have is equal to 50, that's 80 plus this, that's 104 minus 14. Minus 14 minus 10, that's minus 24 minus 22. You know those values, that's minus 46 plus number of chemistry intersection physics intersection biology. So 68 is equal to 104 minus 46. That will give us 58. 58 plus that value there. So that will be equal to now what? 58 plus number of chemistry intersection physics intersection biology. So now you can now make this subject of the formula, or you subtract 58 from both sides. Let's say subtract 58 from both sides. We are having 68 minus 58 is equal to 58 minus 58 plus number of chemistry intersection physics intersection biology. So which is equal to 10 is equal to number of chemistry intersection physics intersection biology. So the value for the number of those, all the students that cheated in all the three subjects is what? Is 10. Now the question we have here says that in a survey of 100 workers. Now that survey of 100 workers that we have here, that is the universal set, is equal to 100. This is the symbol of universal set. In a survey of 100 workers, 41 read Punch newspaper. I'm going to represent those ones that read Punch newspaper by P. So now, number of P now is equal to 41. Then we have 29 reads Times newspaper. Times is represented by T, is equal to 29. Then 26 reads Ovation. Number of people that read, workers that read Ovation is equal to 26. Now, after we've been able to get this out, then we have the information that goes further according to the question here that says that 15 reads Punch and Times. Number of Punch intersection times is equal to 15. Now, what do I mean by this intersection here? Because those are the one that read the two newspapers together. And when you have the and there, that means the intersection. And 8 eerie signs and ovation. Number of times intersection ovation is equal to 8. And the number of punch intersection ovation, that is what you are going to have next. That is 19. 19 workers. Number of workers that read that is 19. And 5 workers read all the 3 magazines. That is number of punch intersection ovation intersection times is equal to 5. Now, you can see that these are 3 different sets that we are going to work on. And when we are working on the number of 3 sets, we need to have the number of those that read all the 3 newspapers. That's going to be number of punch, union times union ovation that involve all the 3 of them. Now, with this information that we have been given from this question here, it can deduce that this analogy can be transformed into this Venn diagram of this nation. This is punch, this is ovation, and this is times. Now, I represent these 3 set diagram and this is going to be the universal set, which is got what 100. Now, I want to use this diagram now to illustrate for you how you can get the particular question we are asked to find. Now, we have been given that the number of those that read punch is 41. 41. That of war times is 29, and this is 26. That's ovation. Then for the punch intersection times, as been given to us here, I do not want to rough this part. Punch intersection times, that is punch intersection times, that's 15. Then times intersection ovation, that is this and this, that's 8. And this is 19. Now, I've been able to manage the space here. Now, the question for us, then there is one that said that of all the 3, that is this position here, that's 5. So all this set diagram has been filled up. Now, the first question that we have there is that find the number of workers among the 100 that did not read any of the 3 newspapers. So you can see that what is the question, what is the answer you want to deduce from here. So with our question given to us now, this is the portion we are asked to find. Number of workers that do not read any of the 3 newspapers. So that now, we now need to find the value of this one first, all the workers that read all the 3 newspapers. You will be wondering that after all these figures have been provided, but you cannot make use of this figure like this. You still need to do some subtraction by saying this 41 now. If you want to make use of this Venn diagram, you have to subtract this one from this 41 minus this minus this part 2. That's going to be the only value here. Then this one will be this one minus this. That will be the only value here. So, but we are not making use of that now. So, number of I can now say that number of punch union times union ovation will be equal to number of punch plus number of times plus number of ovation minus number of punch intersection ovation minus number of punch intersection times minus number of ovation intersection times plus number of times punch intersection times intersection ovation, which we are going to have as number of punch, that will be 41 plus 29 plus 26 minus 15 minus 8 minus 19 plus 5. The whole thing that we have here, which is the value for number of punch union times union ovation, that's what we are working on now, will be equal to, this will be equal to 96 minus 42 plus 5, which is equal to 96 plus, that's what, 101 minus 42, which is equal to 59. That is going to be number of punch union times union ovation. That is the value for that. Now, for us to find the number of workers that do not read any of these 3 newspapers at all, number of workers do not read any of three newspaper will be equal to the universal set minus number of workers that read all the three newspapers. That's number of Punch, Union Times, Union Ovation. Those are the numbers that read all the three newspapers. The universal set is all the survey of the workers, numbers of workers that are put into survey. So that will be equal to 100 minus 59, which is going to be equal to 41. 41 workers are the number of workers that not read any. So the numbers of workers that you find out here in this Venn diagram will be equal to 41 workers from that so-called 100 workers. Now, for the other question we have here that says that we should find how many workers read one of the three magazines. How many workers read one of the three magazines? Workers that read one of the three magazines will be equal to, now, at least one of the three magazines, that will be equal to workers who read at least one magazine who read at least one magazine minus workers who read at least one magazine minus workers who read at least two magazines minus workers who read at least two magazines. Those are numbers who read one magazine, one of the three magazines, at least one of the three magazines. That will be workers who read at least one magazine minus workers who read at least two magazines plus workers who read all the three magazines plus workers who read all three magazines. So that will be equal to, so let's find it out. That will be workers who read all the three magazines, that is at least one of the magazines. That is going to be equal to what? Number of Punch, Union Times, Union Ovation, that is going to be equal to 59 minus workers who read at least one of the three magazines. Those are the intersection workers. That will be minus 15 plus this one, 15 plus 19 plus 8, then plus 5. That will be equal to, so the number of workers who read one of the three magazines, at least one of the three magazines, that will now be equal to 59 plus 5 minus 42. That will be equal to 59 plus 5, that is going to be equal to 64 minus 42. That will be equal to 22 workers. In this question we have here, the question says that in a class of 22 students, one or more of the students take chemistry, economics, and government. The question says that 12 take economics. 12 takes economics. 12 takes economics. Economics is represented by E here. I have it as E. 12 takes economics. And 8 takes government and 7 takes chemistry. 8 government, 7 takes chemistry. So I use the first letter from each of those words to represent the particular element. Now, the question also says that nobody takes economics and chemistry. So economics intersection chemistry is equal to 0. Then also it goes further to say that 4 takes economics and government. Economics intersection government is equal to 4. And we also have it that we are now that is all now. Now the question now says that how many students takes one both chemistry and government. How many students take both chemistry and government? And the other one question says that how many students take government only. Now this is how you are going to solve this kind of a question. I'm going to make use of a Venn diagram in solving this nature of a question. Now this is my Venn diagram now. I'm having the 3 subjects for how many students? 22 students. So our universal set is equal to 22. Universal set is equal to 22. Now, the question says that this is government, this is going to be our chemistry, and this is going to be our economics. Now, the question says that 8 takes government. This is going to be 8. This is not the value for those that take government only. These 8 are the number of students that take government, and some of them still take other subjects. I'm still going to show you how you can get those values now. So stay tuned. So the question also says that 7 take chemistry and 12 takes economics. 12. Then the question goes further that says no student takes economics and chemistry. So this is chemistry, this is economics, this is going to be 0. That is their intersection. It's going to be equal to 0. Then the question goes further to say that we should find the number. It says that 4 students takes economics and government. This is economics and government. This is 12. This is what? 4. 4 students take economics and government. Now we are asked to find those ones that take both government and chemistry. Chemistry and government, the same thing. We are asked to find those that take chemistry. So chemistry intersection government now, let it be equal to x. Let's represent that particular part by x. We are now the value for this place will be, you subtract this intersection value from it. 8 minus 4 minus x. Those are the values that are in the intersection. This place will be, you subtract this intersection to 12 minus 4. Then you subtract this particular value, these two. You're supposed to run these two. But because this is 0, this is 7 minus x alone here. Then we have the value here. Let's take it as x there. So we are going to now have the whole thing will be 8 minus 4 minus x. Then plus this x here, plus x, plus 4. This 4 here, plus 7 minus x. This is what we have here. Plus 12 minus 4. 12 minus 4 is equal to 22. So 8 minus 4, that will be equal to 4. I've cancelled this. 4 plus 7, that's what? Plus 4 plus 7, that is equal to 11. Then 12 minus 4, that's what? Plus 12 minus 4, that's 8. Minus x plus x. This one will cancel this out. We have cancelled this out. We have cancelled this out. Minus x is equal to 22. So 4 plus 11, that's 15. Plus 8, that's 23. 23 minus x is equal to 22. Where minus x will be equal to 22 minus 23. Minus x is equal to minus 1. Because minus x, you can see there, I transfer this here. Then we cut the both side, divide both sides by minus 1. It's going to cut it off. X will be equal to 1. X is equal to 1. So that is a value for those that take both chemistry and government. For both, that is chemistry intersection government is equal to number of chemistry intersection government is equal to 1. Number of chemistry intersection government is equal to 1. So those people that are here are just one student. Government only. For government only now. For government only. That is the second question. One question. For those students that take government only, that will be 8 minus 4 minus x. 8, what do you have here? 8 minus 4 minus x. That will be equal to 8 minus 4 minus 1. Minus 4 minus 1. That will be equal to what? 8 minus 5, which is equal to what? 3 students. 3 students. 3 students. 3 students take government only. So if you are asked for the number of students that take these particular economies only, you have seen it there. Chemistry only, that will be 7 minus x. That will be 7 minus 1. That will be 6 of students that take that particular subject only.